So I've got this little game I just built over the last like 20 minutes. And what I wanted to demonstrate was what you can create with the OnMove function of the movable ball. Um, our ball is able to swim, which is fine because, for example, I can't climb up this thing to this maybe this red target without the help of some platforms to get me there. And so you can see that this blue sphere is, or this blue box rather, is following the sphere. And it says sphere Z is equal to box Z. So as I travel out in this Z dimension, the box goes with me, which becomes, but I can't get up on that box unless I use something that gets me up in the air. Well, I've got this green box moving forward or moving up in the Y direction every time I move out in the X direction. So if I combine these two, I should be able to get up onto this ramp and then transfer from the green to the ramp and then from the ramp to the blue. And now if I move forward, I can trust that the box comes with me. And here I am arriving over here onto this platform. What happens when I go into the red? Shoots me up onto this cone, emits some particles from the cone, and I've landed here. So this could be the beginning of level 2. And something interesting to kind of happen in this world. A simple kind of potential game mechanic. There's a lot of other things like this, but it's a great little demonstration of the OnMove function. I'm going to show you the OnMove function or the OnMove event right now. So if we the best to practice this with is with the movable ball. So we'll go to actors and bring in the movable ball. And now, if you press play, I always like to kind of tune how reactive the movable ball is. I'll often actually come into its properties, and under the movable object actor down here, I'll crank the power up to maybe something a little higher, and then it's a little bit more reactive and moves a little faster. Entirely up to you. So if we press G, we'll get the grid view, and you'll see that the X direction is out in this direction. Z is kind of out and to the left. And when you start in Simmetri, you're sort of at this compound angle of you're in like the negative Z, negative X part of the quadrant, and positive Z, positive X is over here. X runs off positive, off into the distance to your right, Z off into the distance to your left. So you can now say that, if I move this ball into the positive X direction, I can now say something else will happen. So for example, we could make the time of day decrease as we move out into the X, and so that there's like sunrise is somewhere here, and then sunset is somewhere here. So let's do exactly that. So this sphere here has, and any physical spatial object, any of these nodes that you put in space, has the OnMove event, and you'll find it under properties, under the top level, under events. So over here where you see the name and the active state, whether it casts shadows or not, its color, it has these events. And if you expand events, you'll see on a knit, that gets called at the very beginning of the show, when this ball arrives and registers in the earth. So the absolute very first frame of the when you press play, this init function gets run on tick, gets run every frame, and the OnMove function is the one we're going to be working with. That's when anything rotational or positional changes on the sphere. So if it gets moved on its own, or you move it through controls, it's going to call this function. And it's a very useful function for things that are kind of, there's a lot of different interactions that are sort of movement based, or you want to happen only when something moves. Maybe it's emitting a sound when it moves, or it emits particles only when it moves, or relative to its speed, or you're sort of using the object maybe as like a virtual or sort of 3D or kind of spatial switch or something, and you want something relative to something else's position. Maybe you want, like those cubes we had, something to follow it. That's a great place for the on move. And it's also a little bit more, on a technical level, processing efficient than on tick, because on tick gets called every frame regardless, and on move gets called only when the thing moves. On render is when it's actually in view, and that's important for some more advanced, concepts, and being able to kind of save render actual visual computational cycles. And so you can ignore that for now. So we're gonna work with OnMove. So we've selected our ball. Here we are. We've come down. We've expanded events. We're gonna click OnMove. When we click on Move, here's the OnMove function. It's empty now, but it's a perfect place for us to put. This is the place for us to put our function. So what we want to do is get the time of day value, time of day. So if we go out into the X direction, we're going to increase the time of day. And so time of day is handled under the sky space. So clicking in the sky, you're going to find time of day. And time of day runs from 0 as the minute right after midnight, effectively, to right up to midnight at 24 hours. So each of these is like an hour and then a percent of that hour. So what we will think about is that if this ball basically travels out in the X, it'll start off at 0x. So that'll be like, midnight. And then at about 7 meters in the X direction, the sun will rise. And then at about 16 meters, the sun will set. And then it will be dark again. So let's set that up. So what we're going to do is drag in the sky space into our OnMove function. And then basically the OnMove function is being called on this sphere. So if we get our position at any given frame, so OnMove is as that ball moves, if I call a function of getting my position on the self, or mesh entities referring to the sphere here, if I call self get world position, position, and I get the X component of that, get world position dot X, I could say that, for example, I might say sphere X equals self get world position, get the X component of that. And so now sphere X is getting updated every time we move to be this single dimensional value in the X direction. So which means that if I now set the sky spaces time of day equal to this amount, I should sky space dot time, camel case, time of day equals sphere X. I should now get every time this ball moves, it should be updating the time of day value to be the same as my X. And let's see what happens. Rolling just as we expected. So we roll out to about 8, and at 16 it's sunset. And already you have just connected space and time in a funny way. So now there's this like band of this like actual spatial band of daytime. So daytime kind of lives in a volume. Oops. Sort of like, excuse me, sort of like this. Like this is daytime in a sense. Sunrise, sunset. See, does it go? Does the value repeat? It doesn't. It maxes out at 24. And then, of course, simple math if you wanted. Now that we have an OnMove function, a function on our sphere, we can just right-click it and hit Edit Code, and it drops us back into any of the code that lives on this movable ball. You'll see now that we've done OnMove, we've selected OnMove. It now is brighter than the functions around it. That means there's an actual function in the script that's been written. And that object script appears, which says we have an object script living on the movable ball. And also this little pink icon, this little kind of code icon, chevron/chevron, shows up on the movable ball. And you'll see that same little icon over here in the hierarchy view of the movable ball. It shows up. And so over here, or in the space, I can right-click and hit Edit Code. Let me do that again. Right-click and hit Edit Code, and our code will come up. So you can iterate with it really quickly. And so let's say I wanted to span daytime over a longer distance. I might just divide this by some value. Say, for example, when I'm at 24 meters, I don't want to be at 24 hours. I want to be at 1/4 of that. I want to be at like 6 hours. So I'm still in the morning. So this should, by dividing out this value, I will stretch out daytime across space. And there you go. That's the OnMove function, and there's a lot of kind of fun you can have with it. Another little one I'm going to leave you with is how that platform worked. So if I just take a box and make its rigid body movable false, and then what I'm going to do is set its position based on this sphere. So we're going to do that first platform, and that should send you on your way to making potentially a whole platform world. So the way that this is going to work, let's make it a different color. Let's delete this and make this. We'll go ahead and make it green like I did on the other one. And basically, in our OnMove function, we're going to do something different. I'm actually going to get rid of this sky space code, this daytime changing code, but I'm going to leave the sphere X, getting our position in, getting our X world position of our sphere every time we move. What I want to do is set the position of this green box every time this moves. I want to set this position, and I want to set it relative to the sphere's position. So I'm going to connect the X position of the sphere to the Y position of the box. So let's do that now. What we need to do is bring our box into this code, into this scripting, into this script in the scripting window. So we're going to select the box, then grab its icon here, and let's actually bring it into the top. Bring it in right above. It's good to kind of, from an organization standpoint, kind of declare out your variables here. So sphere X is a value of our self's world position. So what we're going to do is basically make sphere X our Y value of the box entity. And then I think we'll just use 0, 0, 0. So the function to set a world position is basically just like this. We're going to say : set world position, and then we're going to give inside the parentheses a vector 3. And let's do that now. So we're going to say box entity 2, matching this name, set W world capital P position. It doesn't matter how many kind of spaces you put throughout here. I open this up so that you can kind of see what I'm doing. Vector 3 is the internal function for creating a vector out of 3 values. and that's going to be something, comma, something, comma, something. And we're going to basically, as I said, do 0 in the x. So this thing will stay in the right around the origin on the x and z, but it'll move up and down in the y direction based on our sphere's position. So basically this one value, this y value that's here, that's where we're going to put sphere x. So I'm going to make a vector. I can bring this back down. We're going to make a vector out of 0 in the x direction, sphere x's value in the y direction, and 0 in the z direction. And that's the vector we're going to pass in to this function of set world position that's going to happen on the box entity. So it's going to set this box entity's position in the y direction, y dimension, relative to the sphere's x dimension. And we press play. There's a little jiggle of this sphere, and this function gets called, and instantly it sets it to, our sphere is in the negative x direction, so all of a sudden it sets this under the terrain in a negative y direction. So you'll see that if I move out to the positive x, up comes this green box. Now that could be, you might say, I just want that to be some indicator, and I don't want a rigid body on it. Or you might say, oh, that's interestingly like a platform, and you'll notice that if I bring the ball right up to the origin, it's kind of scooped up by the green box. You can even get trapped under there, and you have to kind of fight your way out in the positive x direction. So there you go. So you could play around with that function, the OnMove function. Again, once you've created a function on the sphere kind of top level, you can always right click and hit edit code to bring it back, and you'll be able to do all kinds of things, setting different objects' positions based on some mathematical function of any value. And frankly, it doesn't have to be based on the sphere's value, right? Like, as I'm moving, I could set other objects based on anything. Just a very fun little function to kind of play with, and hope you enjoy it.